We begin with a very simple equation. Everybody knows. Okay. Long time ago, okay, Chinese discovered that if this side is 3, this is 4, and this side must be 5, as long as it's the right angle. Okay. As long as it's the right angle. Okay, so this was discovered by Chinese. Okay, and that's the relationship between the three sides. But the Chinese did not, ancient Chinese did not figure out the general formula. Okay. It was actually late, yeah, it was the general formula was discovered by the Pythagorean people. Okay, so that's what called the Pythagorean theory, otherwise called the Chinese theory. Right, so Pythagorean. The Pythagorean theorem says that the complete statement is as follows. You have a triangle, right? It's not necessary to be a right triangle. So it says that this angle, okay? This angle we call it alpha, okay? Alpha equals 90 degrees if and only if it's right angle, if only if a squared plus b squared equals c squared. That's a complete statement. That means if you know a squared plus b squared equals c squared, then this must be right triangle. And conversely, if it's right triangle, a squared plus b squared must be equal to c squared. Okay. So sometimes if you're given three sides of the triangle, if they're satisfying this equation, a squared plus b squared equals c squared, then it's right triangle, so it's much easier for you to do that, to find the area. Okay. And we still go back to the discovery, right? The Chinese, right? 3 squared, right? 3 squared plus 4 squared equals 5 squared. Okay. This is then if you form a triangle, this side is 3, this side is 4, this is 5, and then this must be the right triangle. Okay. Now, can we find here's a question. Can we find the integers, other integers? Okay. Are there, question. Are there other integers? Okay. A, B, C satisfy this equation. Okay. Some of you probably remember, right? Memorize them. Or I can double it, and if I double the triangle, still the right triangle, right? So if I double the triangle, then you get 6, 8, 10. I think this still be true, okay? So 6 squared plus 8 squared equals 10 squared, but it's not essentially new, okay? Right? It's 36, right? 36 plus 64 equals 100, see? We're trying to find some different. Okay. All of them are integers, and a squared plus b squared should be equal to c squared. Okay. How do we do that? I find out there's an important identity. Okay. Here's an important identity. Okay. It goes like that. 2n squared plus n squared minus 1 squared equals n squared plus 1 squared. Okay. So so this is a very useful identity. You can verify this identity. Okay. N is going to be n is integer, so n squared minus 1 is integer, n squared plus 1 is integer. Okay. Now you notice that if n is an odd number, then all of them again, yeah, it's a factor divided by 2. So you can also say, yeah, this is a particularly useful n equals odd number. Okay, if n is an even number, sorry, when n is an even number, then you have a, yeah, when n is even, okay, when n is even, then n squared minus 1 is odd, n squared plus 1 is odd, then 2n is 4 times, right? It's a multiple 4. So what happens when m is odd? When m is odd, so let's see. We still use the above formula, but we're going to simplify it. It's 2k minus 1, okay? That's when it's odd, okay? This is a 2k. Then I put into there, it's going to be 2k minus 1 square, and this will be 2k minus 1 square minus 1. Okay, it's 2k minus 1 plus 1. Let's simplify this identity, okay? And then I get, anyway, I get 2k minus 1. I'm not going to simplify this part. But here, you will see that when we cancel out, I get 4k squared minus 4k. Okay, got it? Yeah. 4k squared minus twice of 2k, that's 4k plus 1 minus 1, okay? And this would be 4k squared minus 4k, but then plus 1 is plus 2. So both sides, all the numbers divided by 2. So actually you can delete 2. So you get 2k minus 1 square equals 2k, right? And the 2k square minus 2k, okay? This is plus, okay, this is plus. And that will be 2k square minus 2k plus 1 square. So you get another identity, okay? And that also gives you lots of new special right triangles, okay? Yes, so only this term is even, other 3 are odd numbers. Other 2 are odd numbers. This is even. This is odd, right? And this is odd, okay? And here, only 1 is even, but the other 2 probably both are odd, okay? Right, so we, so let's write down the 2 formulas. 2n squared plus n squared minus 1 squared equals n squared plus 1 squared. This formula is more useful when n is even, okay? But when n is odd, I can write it like this. X squared equals 2n squared minus 2 plus 1 squared, okay? So this n can be arbitrary, okay, actually, okay? All right, so let's using any of these equations to get some identity. So let's choose n to be 2, okay? So when n is 2, okay, use the above equation, I get 4 squared. 2 squared minus 1 is 3. And that nothing's new here. We already know that. Okay, let's use the first equation, okay? I only choose even numbers for the first equation, okay? So yeah, I'm going to use it by the first equation. Okay. By the first equation, n to be 2. When n is 4, it's going to be 8 squared plus 4 squared minus 1 is 15. Right? 15. So you get a brand new special right triangle. 15 square and then 4 square plus 1, 17. Okay, great. So n equals 6. 2 times 6 is 12 square. Okay, 6 square minus 1, 36 minus 1, 35 square. And then that will be 36 plus 1, 37 square. You see, you get a bunch of special identity. Okay, and then one more. Okay, Those are the special right triangle. Right? When n equals 8, when n equals 8, I have 16 squared. And 8 squared minus 1 is 63 squared. 8 squared plus 1 is 65 squared. All right, so those are the special right triangles. I hope we can memorize them. Okay. Another one is, let's use a second equation. Let me write down the second equation. Okay, it's 2n minus 1 squared plus 2n, actually, this is 2n squared minus 2n, so I can even write 2n n minus 1, okay, square equals 2n squared, actually forgetting this, minus 2n, okay, so let's try. When n, I cannot use n equals 2, 2 is, when n equals 2, right? When n equals 1, then it's trivial, okay? When n equals 2, 2n minus 1 is 3. Okay, 2 times 2 times 1 is 4. You don't get anything new here. And then this will be 5, because 2 times 8 minus 4 and plus 1 is 5 squared, okay? Okay. Right? So, right, so let's let n to be 3. When n is 3, 2 times 3 minus 1 is 5 squared, right? And plus 2 times 3 times 2, right? Right? Yeah, 2 times 3 times 2. So it's going to be 12. And then here will be 13. You will see that 2 times 9 minus 2 times 3 plus 1. Okay, 18 minus 6, 12, right? And it's going to be 13 squared. You see, 12 plus 1 is 13. Okay, great. You see, you will get another sequence of special triangles not covered here, right? Yeah. So n equals 4. Okay, n equals 4. 2 times 4 minus 1 is 7. Okay, and then this will be 2 times 4 times 3. Okay, that's going to be 24. And the other one, I'm pretty sure, is going to be 25. Okay, right? 25 or not. Just differ by one constant. So these two numbers are differed by 1. Okay, you see that, right? The first one, yeah, this is like a 2 n minus 1 plus 1. So they are they're differed by 1, right? Increased by 1, the difference. And here you look at all the number different by 2, right? 15 to 17, 35 to 35, and 35, yeah, 37, and 3 and 5. Okay, so this is the difference is by 2. Okay, so difference is 2. Here difference is just only 1, always 1. Okay. All right, n equals 5. 5, 2 times 5, 10. 10 minus 1 is 9. Okay, plus 2 times 5 times 5 minus 1, 4. Okay, so it would be 40, right? And then this will be 41 squared. Wow, that is new to me. I never, I did not memorize all of them, special right triangles. All right, so if you still really want to get another one, n equals 6. Okay, 2 6s minus 1 is 11, right? Right? 2n minus 1, 2 6, right? The first, you see, 2n minus 1, 2n minus 1, 2 times 6, 12, right? Okay, plus, and that'll be 2 times 6 times 5. So what is that number, right? It's give me 60 squared and 61 squared. All right, so those are the interesting special right triangles, and so you can quickly find yeah. So if you are given a triangle, okay, with edge lengths, with edge lengths like that, it's 11, 60, and 61. We wanted to find the area, okay? If you ask to find this, this is pretty strange. We never heard about, because 11 square plus, the first thing you have to check is whether it's the right triangle, okay? Because those two numbers differ by 1, right? So you double check 11 square plus 60 square, whether this is going to be 61 square, right? So 121 plus, right? It's going to be 3,000, right? 3,721, and 61 square, right? 61 square, you can also do the calculation, okay? And let's double check, this is 61, right? 61 times 61, do direct. It's also 3,721. Wow, amazing, right? So now we discover, using the above two formulas, you can discover so many special right triangle with integer lengths. Okay, I did not find, I just did it by myself. I create this identity so I can generate so many special right triangles. Okay, therefore, H could be viewed as this right triangle by the Pythagorean theory, right? You have to say that by Pythagorean theorem, it is a right triangle. Because it's a right triangle, so you can use 11 can be viewed as a height, so the area is half base times that, right? And then the 30, so it's going to be 330. Okay? That's how do we find the right triangle? Okay. How about it's easy to memorize it. It's 2n minus 1. Now I memorize it. Okay, it's 2 n squared minus 2n, and here's 2n squared minus 2n plus 1. Okay. And yeah, so you can create another one, brand new one. Okay, n equals 7. Let's do one more, right? 7. Okay, so 7, 2 times 7, 14, 14 minus 13, okay, and plus, and here's a 7 times 2 times 7 times 6, okay, and when you multiply this out, 2 times, now this number is going to be larger than still smaller, 100. So I think this is also new to me, and I did not see this kind of special right triangle before. But the 1384, 85 is a pretty nice number. Do we get 13 somewhere before? Yeah, let's play with that. Okay, I don't see 13 here. I don't see 13 here. But I do saw anything 13. Nope. Right. 4 square, 8 square, 12 square. We don't see 13. Okay. Oh, we see 13 here. Yeah, that was a 13, the number 13. Okay. Okay, so you get, you can list all the, actually you can list all the right triangles such that ABC are less than 100, okay? It's possible, but if you use my formula here, you can get all of them, right? All right, so let's take a look at the next problem. Okay, we are given an isosceles triangle. Okay, this is an isosceles triangle. Okay, so it's 17 and 17 and 30. We want to find out the area. Okay, now before we do this problem, okay, we know that this is you're trying to find the height. If you find the height, then you can solve the problem, right? But once you draw the height, right, then use a Pythagorean theory, right? You can find it. So the bottom side is 30, right? Here's a 15 and a 15. So the difference between 15 and the 17 is 2. So that means I probably have to use the first set of a special right triangle. Do we remember where you can get 15 and 17, right? 15 and 17. Now we don't have it, right? So differ by constant. 15 and 17, see? Right? So when A equals 4. So clearly, yeah. So you already know that 8 squared plus 15 equals 17 squared. You can find it by yourself. So H must be equal to 8. Okay? Right? Therefore, the area is going to be the base times height. Okay? The base times height. Okay? So it's going to be 120. Okay? It's going to be 120. You know, you have a super memory, so you can memorize a lot of special right triangles. I only memorize a few of them, but I do memorize a special formula, so I can write down lots of them. Okay. So now let's take a look at the special triangle. Special triangle. This time we are given 30 degree and 60 degrees. This is a right triangle. Okay. So this triangle here is A and B and C. I want to find the relationship between among A, B, C. How can I find it? Okay. I know A squared plus B squared equals C squared, but that's true in general. Does not mean it's not necessary for the special one. I can duplicate, okay, clone this triangle and put it aside. What do you find out here? This side is also 30 degrees, that's a 60 degree. So you get an equilateral triangle, right? If it's equilateral triangle, then this must be C, this must be A, right? So, but the C and the relation between C and A is clear because C should be equal to double A, okay? Right? In other words, A over C should be equal to 1/2. Okay, that's a relationship. How about the B? Okay. A is half of C anyway, right? So in other words, A is half of C. Okay, A is half of C. Now, by the Pythagorean theory, B squared is going to be C squared minus A squared. So I replaced by half of A replaced by half of C. Then you will get C squared minus C squared over 4. So after simplifying, it's 3/4 C squared. Then you get square 3 and square 4 and C. So you will get, yeah, I'm sorry, this shouldn't be just B, okay? So then you get square 3 over 2C, okay? So now for the special triangle, if this is 30 degrees, this is right angle, here's C and here's A and B. A is going to be half of C, B is going to be square 3 over 2C. Okay, so that's a special triangle. Okay, and similarly, you can also look at this special triangle. It's an isosceles triangle. It's 45 degree, 45 degree. If this is C, and these two sides must be the same. Okay, and this must be square root 2 over 2C. Or you can write in this form. But I'm not going to derive that. This is easy from the Pythagorean theory. All right. So let's do some exercise. Okay, I have a triangle. Right, this side 30 degree, this side 45 degree. Okay, and that's ABC, right? All right, I know AB is going to be 2. Can we find the AC, the length of AC? All right, can you try? Yeah, please try it. All right, so how do you solve this problem? The sum of 3 angles will be 180 degrees. Okay, so that angle A is not a 90 degree. It's not a 90 degree. You can you actually so you can get if you really want to find it. Okay, it's going to be 105 degree, I think. Yeah, add them together. Yeah, 180 degrees total. All right. So how do you solve this problem? Okay. All you have to do is in geometry, you have to draw addition lines. Okay. In geometry, you have to draw addition lines. So this is a 2, right? This is 30 degree and this 45 degree. So what I'm going to do is I'm draw addition line. Then you're going to write a triangle, right? Okay. So this side, H, this is A, I'm going to call the B, okay? So step by step, okay. H is going to be half of the other side, it's just 1. Okay. And A is going to be square 3 over 2 times 2, so it's a square of 3. Okay? Yeah. But since this is a 45 degree too, right? This is the isosceles right triangle. So B should be equal to H, should be equal to 1. All right. So what is the area of the okay, then AC, right? ACB. You can even find the area of this triangle. So AC by the Pythagorean theory, AC is going to be square root of H squared plus B squared. This actually is the same, right? It's a 1 plus 1, it's a square root 2. So we find all the sides. Find all the sides. By the way, if you give an equal triangle, how many of you memorize the formula? Okay, or you can derive the formula. So the area is going to be square 3 over 4 times A squared. Now, do you know how to get this? How do you get this area? Okay. You want to find this area, just find the H, right? and this is a 60 degrees, so that will be 30 degree, right? So using a special right triangle, h is going to be square root over 2 times a. Okay, so therefore, the area is going to be the base times the height. So therefore, it is going to square root over 4 a squared. Now, all right, so now what I want you to do is, I have a triangle like that. Okay, this is A, B, C, and D. We know that AB equals AD equals CD equals GD. Okay, and equals what? I don't get this. That is equal. Okay. Then BC equals square root of 3. We want to find out, the area of the triangle A, B, C. Okay. So can you work out this? Right. Any idea? You have to step by step to get what? You want to find the area of this triangle. And that triangle is, it is an equal triangle because AB equals AD equals BD, right? So all you have to do is just find oh my God, my file is gone, something bring it back. All right, all I need is to find the side length of the equal triangle. Okay, because this is an equal triangle, right? Okay. I needed this side A, this is A, right? We also know this is A, right? Okay, so the question is, what is A? Right, to solve this problem step by step, this will be 60 degree, right? If this is 60 degree, that'll be 120 degree, right? If that is 120 degree, and these two angles are equal, right? Will be 30 degree and 30 degree, okay? So once you know this 30 degree, okay, 30 degree and 30 degree, and you know what is A, because this side is square root over 2, right? And this is the A, right? We know that square root over 2, this is supposed to be square root over 2 times A, because this is a 30 degree angle. Okay, that's the relationship between those two sides. So that implies A is nothing but 1. A is nothing but 1. Then, yeah. Then, then is the area of the equilateral triangle. Okay, is going to be square 3 over 4 times A squared, right? So just a square 3 over 4. Okay. Our next problem is we have a triangle like this. So A, C, B, and this side is 63, this side is 16, and this is a right angle, okay, 90 degree. Yeah, I draw the line here, and this is perpendicular, okay? Now we're trying to figure out how many ways to find C. Find the C and D, the distance, the height between C and D, okay? If you're able to find it, let me know. There are many ways to find CD, okay? You can use similarity of triangles. You can also use the Pythagorean theory. You can use, yeah, many ways to solve the problem. Right. At least in some way you have to use the Pythagorean theory because this is 36, right? 63 and 16. Right. What triangle, right? We remember, right? And we know 16 squared plus 63 squared equals 65 squared. Okay, so you know A and B equals 65. I'm going to use the most stupid way to do it. Okay, use the Pythagorean theorem because we want to apply Pythagorean theory. So this is H. Here's X. Here's Y. Okay, first of all, X plus Y equals 65. That's the first equation. Second equation, X squared plus H squared is 63 squared. The third equation is Y squared plus H squared is 16 squared. So you see, you have 3 equations and 3 unknowns, right? So we apply the Pythagorean theory to the right triangle on the left, to the right triangle on the right. And from here, you can find X and Y, then you find H. Right? You cannot find H directly. You have to find X and Y first. All right, so how do you do that? Well, use the elimination method. So equation 2 minus equation 3, H is gone. All right. So how can I do that? If X plus Y equals 65, X squared minus Y squared equals this number. So you can actually fact it. Okay. And X plus Y is given 65. So X minus Y equals, okay. Maybe we simplify this number, okay, if you want. Okay, let's see. Why not, right? Because we'll do the further computation you do need, right? 63 square Okay, let me double check, okay? All right, so 63 minus 63 minus. Okay, so x minus y is this number. Okay, right? It's not going to be integer. So there's no way you can simplify. But at least you have, right, this. So, so add them together, you can quickly get x. Add them together, 2x equals 65 plus 65. So after you simplified, okay. So that is x, okay. That is x. So x is going to be this number. Okay. Then you can find h using any of the equations. Okay. So you find h using any of the equations because h squared plus h squared equals 63 squared, right? So then h is going to be, wow. Okay, and this is a number. Yes, it's a number. You can, but you can solve it, right? You get a specific number, h is going to be square root of that number. Okay, h is going to be square root of that number because you already know x, right? Okay, so if you want to really find h, then this is my answer. But you see, it's pretty complicated, right? Okay. So the best way to do is use similarity of triangle. Okay, or you can use the area formula to do it because you know that this is right triangle. So go back to here, right? It's a right triangle, 16, 63, and 65. This is h, right? So it's right triangle, so the area of this triangle is going to be 16 times 63 divided by 2. Okay? But this area can be also calculated by this formula, right? The base times height. So h should be equal to 16 times 63 divided by 65. It's not too bad. We find h quickly. Right. Yeah, there are many ways to find h. You can use a similarity of triangle also to find it. That's the second method. Okay. The third method is use a similarity of triangle. Use similarity of triangle, you can use the ratio of corresponding sides are equal. Okay. So how do you use this, to review, right? How do you use a similarity of triangle? Well, look at this triangle, right? This is h, this is 16, this is 63, and 65. So take a look at this triangle, right? Copy it here. It's h, 16, and we don't know the other side. That's okay. But this is angle alpha. This is angle alpha. That's a beta, and this must be the beta. Okay, so the corresponding sides, when you compare h and 60, h, right, and 16 corresponding to 15. So h over 63 is going to be 16 over 65. And that implies h is going to be 16 times 63 and divided by 65. Right, so it's the same number, right? We are going to apply the Pythagorean theorem to solve more problems, but today we just get familiar with the Pythagorean theorem. So our next problem, this is a rectangle. Okay. We know that the parameter is going to be 20. Okay. The area is going to be 9.5 square units. Okay. Find the dimension. Find the dimension of this rectangle. Maybe we just want to find the length of the diagonal. That's enough. Yeah, we don't need to find dimension. Dimension maybe complicated. Let's see. And the length of the diagonal. Okay. So this side is y, this side is x. D equals square root of x squared plus y squared. So if you find x and y, you can get d. Okay. All right, so what do we are given? Right? You draw the picture first. Sometimes the picture is not given. Okay? You write down given information. Okay, given information x plus y is going to be half of the parameters, 10. Okay? Area x times y, 9.5 is going to be 19 over 2. Right? Can we find x and y? Or do we really need to find x and y? We actually just need to find x, y is x squared plus y squared, right? Find x squared plus y squared, not x and y. All right, can you figure it out quickly? To get x squared plus y squared? Let's test your algebra. Yeah, that will test your algebra. I speak a lot, you know. I hope you can do some. I figured out x and figured out x squared plus y squared. Okay, any ideas? It's the algebraic problem, right? So if you use identity, x squared, right? Then you don't need to find the x and y individual values. 10 squared equals x squared plus y squared plus 2 times 19 over 2. Okay. So 10 squared is 100 minus 19 is 81. Okay, so that's why d is going to be square root of 81, which is 9. Well, but are you able to find x and y? The answer is yes, but they're not a good number. Okay, let's try to find x and y. Okay, this is just a quadratic question. Okay, you get a quadratic question. So first, you will get y equals 10 minus x, right? And you put into the second equation. Okay. So this becomes a quadratic question, right? Yeah, from here you get this. So get a quadratic equation. So you get 10x minus x squared equals 19 over 2. So x squared minus 10x plus 19 over 2 equals 0, right? It's a fraction. If you don't like the fraction, you can multiply both sides by 2. So 2x minus 20x plus 19 equals 0. And you probably have to use a quadratic formula to find x. Okay, right? So x equals 2 times 2, negative b, b squared minus 4ac, okay? So it's going to be 420 plus minus, okay. It's going to be 400 minus 72, okay? Right, so it's going to be 328, I think, right? Yes. 328, is it divisible by 4 by 16? We don't know. Definitely divided by 4, right? Yeah, it's divided by 4. So it's going to be 4 times 82. Okay, if you take 2 out, take the 4 out, it's 82 over 4. Okay, so it's going to be, we cancel, yeah, 6 plus minus 1/2, 82. So you get 2 solutions. They're both sides are solutions. Okay, don't worry about that. And because, you know, if we x equals 5 plus, okay, then the y equals 10 minus x, which is going to be 5 minus. Okay, so if you choose x to be 5 minus half of square root 82, then the y is going to be 10 minus x, which is 5 plus. Okay, just switch those. So you will, doesn't matter because we're talking about rectangle. So the rectangles, the edge length is not integer, but the length of the diagonal is pretty good, right? The length of the diagonal we already find out. It's gonna be 9. Yeah. So you will get something like that. This is going to be 5 minus half of square root 82, 5 plus half of square root 82. Okay. And this side is going to be 9. This is the only integer you have. So this is only integer. All right, that's the last. So we try, remember we have this is A and the B and the C, right? So the triangles are uniquely determined by the triangle is uniquely determined by the 3 sides. We can assume that C is larger than A plus B, right? So how do we find the Theorem's formula, right? How do we find the area? So the area is going to be square root of S, S minus A, S minus B, S minus C. So S is half of the parameter. Now, is this correct formula? We don't know, right? We have to check. Right? How do I do? I assume that I can draw the line from the top to C, okay? But maybe I cannot do that here because this is from this top to the other side, this height is nothing, right? It's all sides of the edge. of the triangle. Okay, so if we find the height here, it's impossible, right? So this is a right angle. Yeah, I just want to look at this case. We draw the line, and then it will touch the other side. Then repeat the above argument. It's better to without using specific variables. Okay, so x plus y equals c. Okay, then x squared plus h squared equals a squared. Y squared plus h squared equals b squared. So you are able to find the h. All I needed to find the h. Okay, all I needed to find the h, but I have to find x first. So when I take the difference, right? X squared minus y squared, equation 1, equation 2, equation 3. So equation 2 minus equation 3 yields a squared minus b squared. Okay. So x minus y, x plus y equals a squared minus b squared, or x plus y is c. So I get x minus y equals a squared minus b squared equals c. That's equation 4, right? So you have equation 1, and you have equation 4, but you can get x, okay? Add them together, 2x squared, 2x, not x squared, no x squared, equals c. Okay, so my x is nothing but, okay, so you find the x, then you find the h. Wait, okay, you find the h, right? Remember, right? So the picture here. This is A and B and C. This is H. Here's X, Y. So H is going to be square root of H square, square root A square minus X square, right? And I already know the X. Okay, so that is H. But once you get H, you can find the area formula. Area formula is going to be half of C times H. And you may call it formula if you find out under my name, for example, right? This is different from Heron's formula, but you can rewrite, you can rewrite all the variables. Eventually, you can make it look like this, okay? So how do I do that? I move C to inside, right? I move C inside. I don't like the C put outside. So I move the C to the inside, and then 1/2 is also inside. So I get is A squared C squared over 4, right? And then minus, okay, minus, I think C squared is canceled out. And I get 2 squared and 2 squared. Okay. So I actually have a 2 squared times 2 squared. And here's A squared minus B squared plus C squared and squared. You can express the formula in this form. Okay. Well, this is Heron's formula, okay, but it's the expression is different than what he wrote there. Okay. Okay, you can, because they're in the equal position, A and B, C, you cannot say A is more special than C. So what you get here is 16, right? And this is 4ac squared, right? Minus a squared minus b squared plus c squared squared. So I try to express it in the sum, so that a, b, c are in equal position. Okay, this is 4a squared c squared, right? Minus a to the fourth power, b to the fourth power, c to the fourth power, minus 2ac ab squared, minus 2bc c squared, and plus 2ac a squared. Okay. So finally, I got yeah, I can I got what I got here. See, 2a squared b squared, 2b squared c squared, and 4a minus 2 is also 2a squared c squared, minus a to the fourth power b to the fourth c to the. You can call it Heron's formula. It's also easy to memorize. Okay, that is a formula, right? Okay, they are all A, B, C are all in equal position. Okay, it's not like the earlier expression looks like, oh, why here's AC squared, A squared C squared, and here's A squared minus B squared plus C squared. Now after you simplified, you end up with this, and this is indeed all in the equal position. So this is our area. Okay, so if you have a general a triangle, you can always use that. And how do we get that? We just repeat our procedure to get this formula. Actually, as long as you 3 sides given, you can always find the height to use the Pythagorean theory. Okay. Okay. Then you get this very general form. So there, you can relate to this, and then you can write this in the form, yeah, Heron presented in his paper. Okay. All right, so yeah, today I stop here, and you're going to get a homework after the class, and I hope you finish all the all the exercise. Usually you're given 15 problems each time. Okay. Okay. See you. Bye.